about deep learning? So we discussed yesterday about what is deep learning, what are the major types of deep learning. So who is going to explain? Okay, no worries. Can anyone explain? You people can search in, it's fine. I need the answer only. Yes. Who is going to give an answer?
Deep learning is a branch of artificial intelligence, which is based, no, it is a branch of machine learning, which is deeply based on the artificial neural network.
Okay. How it's different, yeah, beneath how it's different from machine learning and which scenario?
Ma'am, your voice is breaking.
Machine learning is for like a start, and if we are every time I make mistake. Am I audible? Am I audible, guys? Let me rejoin, otherwise. Am I audible, guys?
Yes, ma'am.
Okay. Thank you, Sneha. Thank you so much. Okay, fine. No worries. So now let's see. Okay. So what are the major types in deep learning, guys? What are the major types? Like neural networks. What are the major types in deep learning? There is, I'm giving the hint also. There is 3 types of measures, major major techniques in deep learning, like ANN, RNN, and CNN. What is the full form of ANN?
Artificial neural network.
Yeah, artificial neural networks. Good. What is the full form of RNN? You people can text in the chat box otherwise.
Ma'am, recurrent neural network.
Recurrent neural.
Yes. Chat box is enable, guys. Chat box. Please send your answers if you are not able to speak. Send your answers in the chat window. Okay. Recurrent neural networks. And what is the full form of CNN? CNN.
Convolutional neural networks.
Yes, convolutional neural networks. So, tell some names of the deep learning frameworks. Some major names of deep learning frameworks. What are the major frameworks? Like from Google, from Facebook, we are having very good frameworks. Any guesses?
TensorFlow.
Yes, yes, good one. TensorFlow, then
PyTorch.
Keras.
yes, Keras, PyTorch. Yes, correct only, guys. Why you people are not giving response? I don't know. The correct one only. Okay. So now tell me what is neural network or what is neurons? How the neurons are working? Any answer? What is neural networks or the definition of deep learning? Okay, what is the difference between like biological neurons and artificial neurons?
Okay. So, if you want to do the visualized platform, that's fine. But if you want to more interactive visualization, then you can use C and both.
Pawan, please mute yourself,
This is
Pawan.
about your
Fine. No worries. So guys, go through these things. Fine. And what is the difference between forward propagation and backward propagation? Any answer? Forward propagation, backward propagation, any answer? Okay. Guys, you people need to make a note. At least with the words. Make a note so that will be helpful for our future studies. Okay.
Ma'am, many of us were not in yesterday's class, ma'am, because of internet issue at hostel.
Okay. But other people are there, right? Yesterday more like 100%, 100 people joined. So they are there, right? Okay, fine. So deep learning, like how our brain is working with biological neurons, biological neural networks. Same in artificial, using artificial intelligence, we can make the artificial neurons for running a computer program with unstructured data like image, video, voice, speech, this type of recognition, this type of pattern analysis. We are using deep learning, right? So let's go with something practical use case. Okay. Heart failure. So heart failure is a Cardiovascular disease, the most causes death globally, taking estimated. See, guys, we already did one use case, heart failure prediction with classification, right? The same type of use case we'll do with neuron networks, means deep learning. So which accounts for 31% death worldwide because of heartbeat, like heart failure. 31% of people are going for death. Heart failure is a common event caused by cardiovascular disease. It is characterized by heart's inability to pump an adequate supply of blood to the body. Without sufficient blood flow, all major body functions are disrupted. Heart failure is a condition or a collection of symptoms that weaken the heart. Fine. Now, let's go and predict the heart failure rate. What is the table of content here? Import libraries, loading data, data analysis, data preprocessing, model building, and conclusion. The same process is same in machine learning, in deep learning, everywhere the process is same. First, we need to import the libraries. So guys, we are having NumPy and Pandas. So who is going to give answer why we are using NumPy? Why we are using NumPy?
Ma'am, for the mathematical calculations and the like settings values.
Good one, mathematical. And why Pandas we are using? We are
To convert data into data frames, ma'am.
okay, Pranav. So Pandas we are doing for data analysis, reading the file, doing the missing value handle and all. Then for what, for Matplotlib we are using?
Graphical representations and everything.
Yes. The plots, the graphs, the charts. And this pre-processing import standard scalar. Why this scalar we are using standard scalar?
It scales the data, ma'am.
Yeah, it will scale every feature in one scale. For example, I'm giving one example to you people. For example, we are purchasing a washing machine. So if you are from someone from US, they are purchasing with $200, but we are purchasing with 16,000. But the scale is same for both. 16,000 only. Their currency it's $200. Our currency is 16,000. But the scale is same. The standard scaling. You people got it? What is standard scale? Every feature will scale in one scale. That is standard scalar. For example, we are having cells 0 to 1000, age 0 to 100. Whether we will convert 0 to 100 to 0 to 1000 or 0 to 1000 to 0 to 100. All feature needs to be in a scale before model building. Fine. Now, a scale on model selection, train test split. Why we are taking train test split, guys?
Ma'am, it is used for like training the to get the accuracy of the test set.
Yeah, Abrit, it will divide the data into training data and testing data. It will do this split. Got my point? It will
Yes,
do
ma'am.
this split. Okay. Yeah. Now SNS for Seaborn, why we are using Seaborn? Seaborn is the top of a Matplotlib for effective graphs, charts. Now we are using here Keras. Keras is what? Keras is a framework for deep learning. We are using Keras layer. So yesterday we also discussed how many layers are present in deep learning. How many layers are present in deep learning?
Three.
Three layers. Yes. What is the three layers?
Input layer, hidden layer, and the output.
Yes. Input layer where it will take the data. Hidden layer where it will perform the pre-processing, feature selection, model building in the hidden layers, and it will out clear. Is this clear?
Ma'am, your voice is not audible.
Okay, my voice is not audible to you or everyone.
It's breaking in between.
Okay, it's breaking sometime. Okay, no worries. Okay, fine. So, okay, fine. So this is dense. These are the parameters, batch normal size. These are the batch normalization. These are the parameters. Dropout. Dropout means when the neural networks are learning. That time, if it's finding the features are not involving, then it will go for the dropout. Means it will remove the noise data. Okay, then LSTM for time series. LSTM for long short-term memory. Okay. Because we already know this is the sequential model, right? Deep learning. So we are taking sequential and two category. Then Keras callbacks, scikit-learn metrics. How we will do it here? We are going to predict but the classify like it's a risk is there or not. So precision, recall, confusion matrix, classification report, accuracy score, F1 score. This is quite similar as in the classification one, machine learning. Now let's go and load the data. Fine. No worries, guys. You people also need to do with me. So I am sharing this file and data file. Please, you people also need to do practice. So do with me. And this is for everybody. Everybody need to participate. Otherwise, I don't know how much like marks you will get. Please, all of you, open your system.
You're not audible, ma'am.
How many people shared this screenshot?
We couldn't hear anything, ma'am.
Okay, again, explaining. No need to worry. Okay.
Ma'am, your voice is not audible.
Or again not audible.
Yes, now this is fine. Now my voice is clear to everybody.
Yes, not audible.
Now also people are not getting my voice. Seriously?
Now audible.
Audible, right?
Yes,
Yes, ma'am.
Okay. Yeah, please. Okay, so start practicing, guys. Without any time waste, start practicing. Did you people started reading the file?
Access is denied, ma'am.
No, please try. It will work. I already opened. The access will not denied. It's already open. Anyone with the link. Yeah, please check again.
డిఎన్డి ఇచ్చి ల్యాబ్ డిప్ ఇచ్చాను నాకు చేయమని ఆ కథ తేడా కొట్టేసింది రెండు కానీ మీకు నేను
Okay. So guys, I think. Yep. Am I audible now, guys?
Yes, ma'am. You're audible.
Okay. No worries. Okay, it's done. Fine. So let's go and learn more things. Today I don't little bit problem is there. Okay. I think my screen to visible to everybody, right? My screen and voice.
Yes, ma'am.
Okay. Okay, fine. So we're done with the reading the data file. Fine. So I hope you people have some idea like what is the data and all. So now let's go for the data analysis. So death event. This is our target column. What we are going to predict. So we are just giving a count plot. Count plot is coming from Seaborn. We are giving just two colors font, nothing else. So now death event, the success rate is less, means the people will get less heart failure and like they will not get more heart failure. Success rate is less. Now the second one is point to note is that there is an imbalance in the data. We'll check the balance and correlation here. So here you people can see this is the green line, right? So what it's meaning, guys, it is 1 1 1 1 hubbing. What it's meaning? Can anyone explain?
There is no correlation between them.
No, they are highly correlated, na?
Yeah, sorry.
So yeah, see age to age, it's highly correlated. Anemia to anemia, highly correlated. Diabetes to diabetics is highly correlated. See here we are having the, see here. Death event to death event, highly correlated. And here, see, you will find a scale here. It's having 0.8, means it's very less. Sorry, it's having 0.8, it's having 1, means highly correlated. And here it's coming, they are not correlated. See, here it's coming minus 0.4. So they are not correlated, means they are not that much needed for our model. So here we can do the feature selection. You can skip some features. For example, this is here minus 20, 0.22, minus 0.22. So what is it? This is with age with time. So there is no combination of age with time. If you are going with the death event, this is minus 0.53. So death event with time does not matter. Like your heart failure, if you are like no matter what time, if you are doing smoking and taking alcohol and other things, you are having high blood pressure, chest pain, then anytime you can get the heart pain and this heart failure. Okay, who are highly correlated, we need to keep that features. who are less correlated. If that is not needed for a requirement, we can ignore them. Fine. This is about the map. This is called correlation map. Now, notable point, time of the patient follow-up visit for the disease is crucial is an initial diagnosis with cardiovascular issues and treatment reduce the chances of any fatality. It holds an inverse relation. Ejection fraction is the second most important feature. It is quite expected as is basically see. Ejection fraction, where is it? See, this is ejection fraction with minus 0.27 with the death event. Fine. So we will get the little feature importance here. Now the next one, count plot of age. So which age people are more getting heart failure? Like 60 year, 50 year. Now Boxen and Schwann plot, guys, this is your example of these plots, but you people can plot any plot. There is nothing. This is simple data analysis, data visualization. You people can use Power BI also fine. These are the graphs. You people can use any graph. There is nothing like this graph only. See, in this graph, see the data points are. Some outliers also there in the data points. Now the same with KD plot. These are the distribution, guys, nothing else. This is the transport distribution. You people can use any auto IDA also, any graphs. These are the examples, any graph you can use. Now the next one is data pre-processing. So guys, what are the major steps in data pre-processing? Who is going to give answer? Forget about these things. Normal, the major steps of data processing, data pre-processing.
No, ma'am, you are not audible, ma'am.
this time, guys? I think now it's fine. I joined from browser as well. Now it's fine. Okay. Okay. Fine. No worries. Okay. Thank you. Okay. So coming to the data pre-processing, steps involved in data pre-processing, dropping the outlier based on data analysis. We're done with the data analysis, then we'll drop the outliers. Guys, here these are the outliers. See, these are the outliers. You people can able to see who are the outliers. See, something is beyond the layers, it is outliers. You people are getting my point, right? Now, and assigning values to features at X and target is Y. This is the same. We are taking the dropping the target variable, target column, death event from the total one. Total we are keeping in X and only death event column we are keeping in Y. Then we are performing scaling and train test. And after that, what we are taking the column names and scaling. We are taking the standard scaler and we are fitting the transformation. This is the count, 50% standard deviation, 70%. Then we are going with a feature, looking at scaled feature. Now also see outliers are there. So which one having we are having more outlier, guys? Which column? Can anyone tell which column we are having more outliers? You can look at your data and tell me, it's fine. Who is going to give the answer? Any answer? I think you people done with the plot, right? Am I audible or not? Hello? What's happening here? I don't know, ma'am. Okay, then why you people are not giving any response? Okay, and see, other batches are going on how they are giving responses. Your batch is quite like irresponse people, yeah. Why you people are not giving response? 179 people are there. I'm not expecting the correct answer from you people. At least speak up little. Okay. So here we are having this 3 1 serum sodium, then this one also ejection fraction. So depend upon your data, you can get the outliers and you can deal with it. Now we are dividing the data into testing and training. Extend, X test, Y train and Y test. We are doing training test split. And the text size we are taking 0.25. Can anyone tell what is the meaning of this 0.25? How much we are taking for training and how much we are taking for testing?
I'm 25% for the test and 75% for the.
Yes, yes, correct, correct. So 25%. Can I take 30 to 70? Is it okay? 30 to 70 or 20
Yes,
to
ma'am.
80? Can I take 30, 70, 30 for training, 70 for testing? Can I take like that? Yeah, we can take, but that is not the perfect way because 30% how the data, how the model will train. So better will take more data for training, less for testing. Okay. So we are dividing now the training and testing data. So X train and X test, we are giving X train, we are giving like 75% and testing 25%. Fine. Now let's go for model building. So till that time, this is same to machine learning. Like data analysis, data preprocessing, all same. Training, test, split, same with machine learning. Now where the model building is coming, the for we are using now artificial neural networks. So initializing the ANN, defining by adding layers, completing the ANN, training the ANN. Now early stopping. First we need to initialize the artificial neural networks. Callback dot early stopping. Mean delta 0.0 means minimum amount to change to count as an improvement. How it will like minimum it will go with 0.01% improvement in every layer. Then patience, how many epochs to wait before stopping your 20. Then restore best to weights. True, yeah, it will work. Backend it will run. Then initializing the NN like model equals to sequential model we are taking from Keras. See, we'll go with this one. See, the sequential we are taking for Keras model. I mean, now these are the layers. Model dot add. Now this is dense units equals to 16. Kernel initialize equals to uniform. Active version function equals to ReLU and dimension equals to 12. So dense, what is dense guys? What is dense? And yesterday I explained also ReLU. What is ReLU? ReLU is the activation function which will active the neurons. This is the kernel, like how in Jupyter also we are restarting the kernel. And what is dense? Dense is the layer. Fine. So we are adding two dense, and if there is something weak learners, then it will drop out also. 0.25 line, it will drop out. These all are the parameters, the dense. Then again, it will drop out unit for unit 6, unit 8, unit 4, and 1. For example, it will start from 1, then it will go for 4 layers. It will connect with 4 layers, then 8 layers, then 16 layers. Fine. And sigmoid also a function which is using classification. Because we are having less units, so we are using sigmoid. Now SDZ optimizer. SDG means the gradient descent. SDG means a standard gradient descent. Sorry, stochastic gradient descent. I forgot. Stochastic gradient descent. So gradient descent means what, guys? Which will convert the weak learner to strong learner. Now compiling the ANN. So model.compile. We need to compiling. Optimizer equal to Adam. Adam is an optimizer which will optimize the neurons, the output, the neurons. Then loss. Loss function is a binary cross entropy. This is a parameter. Metric equal to accuracy. Where what we will get the accuracy. Now we'll train the model. Same. History equals to model dot fit. Same X train and Y train. Now the base size is 32. We need to give the parameter base size and epochs 500 time it will run. See, in machine learning, it will give the result to be running one time. Again, here it's run 500 times. You can make it 100 times. For example, I will make it only 50 times. Otherwise, it will take more time. So callbacks equals to only stopping. Validation split is 0.2. Now let's run it. You people can see something new here. See. So what we are giving epochs 50. So it will run 50. So from starting, it will start one, it will run one time. In machine learning, it will run only one time, but here it's run one time from 50, and here it's giving loss. Loss means this binary cross entropy it is using and giving 0.69 loss function, and the accuracy is, we are taking the matrix accuracy is 0.63 means 63%, and the validation is 0.69, and the accuracy is 0.66 from the cross validation. This is for testing and cross validation. So we are having 150. Then let's go to the other epochs, 50 to 50. Now you can see in the last, (48) to 50. What it's giving the less, see, now the loss is less. The accuracy is good, 64%. Cross validation also the loss is less, the accuracy is 66%. And the previous one is like 66, 66, 66. But here this is also 66, but the loss is less. The loss is less, 48. See here if you put in 48, 50, it's 48.29. So like that way we will get the better and better accuracy in every epochs. Now let's go for the validation accuracy. This one, validation accuracy percentage. Total validation is 66%, 67. So this model is not that much good. Because at least if you are getting more than 80%, then we can try for more. But 66% is not a good model, right? But now we are having this much data, so it's coming this. If you are having more data, it will come more good accurate. Now plotting the train and validation loss over epochs. So what we take, we'll take the loss and the validation loss. Then we are taking training and validation loss. In the training, how much it is coming in validation. See, when we are doing the training, this is the loss we are getting. This is the loss. But in validation step, this is the loss. So you people can feel the difference. How is it? In validation phase, it's coming like little less, the loss. In training time, it was more high, and validation wise, it is less. So it is good model only as compared to machine learning. In the epochs, we are having 0 to 50 epochs. These are the epoch size. Now, plotting train and validation accuracy. The first normal accuracy, validation accuracy. So validation accuracy is too high. See, training accuracy, this validation and training accuracy lies from here. Validation is upper. So validation is the good one. So we can go with this model. Model is working good. Now, conclusion. Conclusion, the model with testing on the test set, evaluating the confusion metrics like accuracy, evaluating the conclusion report. Right. So predicting the test set result. Let's go and predict the test set result. So why predict less than 0.5? So it's 3 by 3 is coming. Y prediction. Yeah, let's go for the confusion matrix. Confusion matrix means accuracy, precision, recall. And from where we are doing the confusion matrix? From the testing Y test and the Y prediction. Y test means what we are having. Y prediction means what machine is giving the output. Okay, this is my confusion matrix. 0, 1, 1, 0. So the first one is true positive, 0.76. So 76% is coming correct. Other things true positive, true negative. Now let's go and find the classification report. So here precision we are getting 76%, recall 1%, F1 score 86%. These are the report we got. See here 76%, 0.7. So 76% is the true positive, means whatever we have in the machine is predicting both same only. This is quite accuracy 76%. So like this way we will get the result and we will get the output. This is little different from machine learning, but for increasing the accuracy here we need more data. Now guys, any doubt please let me know. Guys, you people also find the accuracy and send me the screenshot. Let's find the accuracy. Let's find the accuracy and share me the screenshot, please. Yeah. You people are doing? Yeah, Abneet. 66% only, Abneet. Okay. Uh, okay. The loss is here, binary cross entropy. Let me go with another. Loss in loss function and they use in neural networks. Hyperparameters, mean squared error, mean absolute error, binary cross entropy. This is called log loss. This is loss function used in binary classification. Okay, binary classification. This one is using categorical cross entropy. In this case, where the number of the classes is greater than 2. So there we will go with binary cross entropy only. And go with simple loss function MSE. It is for MSE for the numerical things. Cross entropy only we can take. Let's go for 100 epochs. Let's go for 100 because we did the less epochs. So it's coming less accuracy. Can you people try with the 100 epochs? Can someone try with the 200 epochs? Please change the epochs and let me know the result. Please guys change the epochs. Epochs means what? Every data point will run one. It will give the accuracy and the next one it will update little weight. Then it will run and give the better accuracy. Okay. Yubras, what is the accuracy it's coming? Huh? 75%. How many epochs you took? Take little more epochs. Try for 90%. Sai Ganesh. 100 epochs is coming 68. Give more epochs now. Vijay. 82. 79. Let's try for more. So guys, how many epochs it will run? It will give good results. Ganesh, 82. 100 epochs only. Little more epochs. We have guys 183 people only. Why some 10-15 people are giving? Everyone try to do it. And who are having first semester, second semester, guys, no need to worry. You can practice aram se. If anyone facing any problem, let me know. I will help them. If you are getting errors, also you can send this screenshot. So I will help you out. No need to worry for anything. Feel free, very comfortable, and send your doubts or whatever you are facing the errors. Take the screenshot and share it to me. I am on live now. I will clear out everything. Who is there? Abhirup, Prata, Sohan, Ujita. What about you people? Please send. Okay. What is the highest accuracy is coming? Guys, please take a proper snapshot. I'm not able to see only. With epochs 100. 74% coming. Let's try for 80 plus na, like 80 plus percent is. I think someone gave me one answer with more than 80%. 82%, 79%. Ganesh, what is the answer? 79%. Guys, please be fast. Give 200 epochs na. 200 epochs, 250 epochs. Let's see how it's coming. Give 200 epochs. 250, 300. Let's beat a try. See, AI is quite interesting. AI is quite interesting, quite enjoyable. So guys, please participate with these things. Try with 200 per epochs. And find the accuracy, average, total average accuracy also. Then print the graphs as well. After doing 200 or 300 change, print the graphs also, see how it's coming. Okay. Where is the accuracy? Is 88%, 76%. No, it's coming the validation accuracy 76%. How many epochs you gave? 500 epochs, 86%. What is the validation, total validation accuracy? Sai Ganesh. Pranav, there is I think two Pranavs. Abhirup, Sohan, you people also need to participate. Sneha, Pujita, girls. Once done with 80% accuracy, go and run this code as well. For example, let me run with 400 or 600 times. Only the demerit is it will take more time to execute. See how it's executing. You can see here. This is like it will take too much time. Ganesh. Okay, 80%. Yeah, good one. 200 epochs is fine. 200% and it's coming 80%. Yeah, it's taking time if are giving high box. So, guys, you people can go with 200, 300 and do the plots. See, execute the down as well. See the plots, how it's working. Share the screenshots on the plots. And see here how much the confusion matrix, the true positive is coming. The print the classification reports. It's all about learning, nothing to worry. Aram se people can do it. Okay, 600. It's still now 150 only running and getting 66% validation accuracy. Loss 0.64. Okay. It's going till 185 only, not more than that. It's having this much only. If I'm going here, then what accuracy is coming? 66%. It's mine or it's not good. Okay, who is getting good one, the highest one? It's 80%, Kanishk. Any other one who are getting more than 80% accuracy? Who are getting more than 80% accuracy? Please set the screenshot. Okay. Ganesh and other people who shared your the graph, the reports. Why not you people are sharing the graphs also? I wanted to see the graphs. Only few people shared. So the graphs also. Okay, guys. Okay, it's fine. Guys, any doubt? Anyone having any doubt with ANN? and this use case or regarding deep learning introduction? Okay, no worries, no need to worry. So coming to this one, this loss function, how we can calculate the loss? Here we are having many loss function, which is applicable when you people can study it. Let me send this one as well. Yeah. Any doubt from anyone, guys? One second, I'm sharing the document. Yes, done. Now let's go and do the another one. Yeah. So this is all about the ANN, artificial neural networks. I hope you people got some idea about ANN. Fine. So what is the next one? That is RNN. So what is RNN? Why we are using RNN? Any answer from anyone? What is RNN? Okay, guys, recurrent neural networks. Am I audible, guys? Okay, my voice is audible, someone? Update? Okay, yes, fine. No worries. So what I'm telling you, see, we have only very few sessions left. Many things we covered. Maybe we'll connect for 3-4 days more or 5 days more. After that, we'll assign the internship projects. So before that, I wanted to do everything clear out, guys. So please be focused for just for more 4-5 days. So please be take it little serious. Okay. So what is the second methodology here? RNN, recurrent neural networks. Right. So it's guys already 9:32, 33. Let's take 2-3 minutes break, and after 2-3 minutes we'll connect. Let's have some water.
నేనేం కప్పులు ఎప్పలేదు మరీ ఉతుక్కుందాం లెక్క నీది ఉతుక్కో ఫస్ట్ ఆ కంపుది చిన్నది హాస్పిటల్ పోయిన గురించి ఎట్లా పడుతున్నా డాడీ ఇది అవునా రగ్గు తీసి ఉతుక్కురా డాడీ చిన్నది నువ్వు తల కింద పెట్టుకుంటావా ఏముంది లేరా మాది హాస్పిటల్లో నుంచి
Hello. Yeah. Okay, guys, let's go to learn something about RNN. Okay. Okay. Fine. Okay. So now let's learn something about RNN. Fine. See, I will not explain everything today, but something we will learn about RNN. And tomorrow I will explain everything. And guys, yesterday's document ANN and today's and tomorrow RNN, everything I will share. And the recordings also, I think it's already uploaded, but still I will check today. RNN. So RNN means what? Recurrent neural networks. So guys, can anyone give a hint or answer that the recurrent data set? Any example of recurrent data set, guys? Any guess? Please do Google also. A recurrent data set. Okay, no worries, no worries. So a recurrent data set, it's like time series. For example, day basis. Every day we are having some work like day basis. Like today, tomorrow, day after tomorrow. And something is week basis. Week 1, week 2, week 3. Recurrent. One after one another recurrently it will occur. In ANN it does not matter it is recurrently or not, nothing. But in RNN, whichever data is in recurrent, that will come up with RNN. Fine. Now the next one. RNN is a deep learning model. Let's go with one images. Okay. See, this one is the good one. So we have three layers. This is same for everywhere. Input, hidden, and output. Right. Now, input, hidden, and output. Right. The same, but this is only normal network, normal neural networks, and here it is like it is iterate. It is recurrent. Only this option, this will recurrent. This is only the difference. Architecture of RNN. For more clear understanding of the concept of RNN, let's look at the unfold RNN diagram. See, this is RNN. So it is XT means input and it is giving output. And this is the layer. It is doing the iterations. Fine. So recurrently it is occurring. So unfold how it's working. First it is taking A, then it is doing 1A T minus 1. It is updating at W. See, it is updating W. So it is coming here. Again it is AT. Again it is going and updating W. It is here. See, it is one thing, but how it's working, this is the example. Again W is update. W means wait, where we'll get more good prediction. Then again it's giving, again it's doing recurrent and it's giving the output. So this is how the RNN used to work. Right. This is the mathematical things, nothing else. Same loss function, same activation function. There is nothing much difference. Fine. Now, recurrent neural networks. What is recurrent neural networks? Recurrent, sorry, not recurrent, no, recurrent. Recurrent neural networks were introduced to address the limitation of traditional neural networks, such as feed forward neural networks like FNNs. When it comes to processing sequential data, FNN take input and process each input independently through a number of hidden layers without considering the order and context of the inputs. So previously today we discussed about ANN, fine. But when we are having the sequence data like time series forecasting or stock price forecasting per day, so this type of data is not able to give good result with artificial neural networks, ANN. So and also FNN means feed forward neural networks. So they introduced RNN. Fine. Due to which it is unable to handle sequential data effectively and capture the dependency between inputs. As a result, FNNs are not well suited for sequential processing tasks such as language modeling, machine translation, speech recognition, time series analysis, many more applications. They require sequential processing because they are having sequential data. We cannot go with the traditional process. So for that, we are using RNN. RNN overcome this limitation by introducing a recurrent connection that allow information to flow from one step to the next. So what it will tell, allow information for, because it is having sequence. So from one day information, it will go for the next day, then next day, then next day in a sequence manner. That is happening in RNN. This recurrent connection enables RNNs to maintain internal memory, where the output each steps is feedback as input to the next step, allowing the network to capture the information from previous steps and utilize to the current step sequence wise. That is happening in RNN, which was not happened in ANN, FNN. So we are dealing with RNN. So I hope now you people got little bit idea like what exactly RNN is doing. Am I clear, guys? So who is going to tell what is RNN and why we are using RNN? Any answer is fine. You people can do Google also, I'm fine. I need the answers. Okay. Someone texted something in chat window. Okay, no worries. Recurrent neural networks. What is recurrent neural networks? The same, the picture is different, otherwise same. Common activation function. So guys, we are having in this neural networks many activation function. For RNN, we have sigmoid. Guys, sigmoid we are using for classification also. Classification one. Sigmoid, H, and T. We have three activation function. One is sigmoid, TANH, and RELU. So a neuron activation function indicates whether it should be turned on or not. Because there is many neurons are like dead neurons that is working or not. For example, in our body, we are getting paralysis or something, some uh, neurons are not working. Then we are not feeling well, going to the doctor and all. Think about a machine, how they will know. So for activating their all neurons, we are giving these three medicines. For example, these three medicines, three activation functions. Some medicines are doing great, some are normal, some are manageable. So sigmoid, TANH, and RELU. Sigmoid is like this way, 1 by e to power minus z, and tan is this way, and ReLU is the good way. It is having always 1 to 1. 0 to 1 only, but it will take the direct max of 0 comma z. It is the better one. See, this will not, it will not go with any exponential value. ReLU is the simple one, maximum of 0 comma z. Sigmoid, the formula is this used for express this. Advantages and disadvantages of RNN. Advantages of RNN is handle sequential data effectively, include text, speech, and time series. Process inputs of any length, unlike feed-forward neural networks. Share weights across time steps, enhancing training efficiency. This is advantages. What are the disadvantages? Prone to vanishing and explaining gradient descent problem. Handling learning, like it is gradient descent problem means if it is going in a sequential manner, it is going like next and next and next, then it is forgetting, it is the vanishing some data from the previous one. Because of this reason, we are having another algorithm that is called long short term memory management memory algorithm, like LSTM. In RNN, we are having a strong and robust algorithm that is called LSTM. From there, we will figure out this problem. Training can be challenged, long sequence. If that is a long sequence, it's training little time. It will take little time. Computationally slower than the other neural network architectures. Then FNF. Back propagation to standard RNNs. what is exploding gradient, what is vanishing gradient, just go through it. And these are some use cases like speech recognition, generation of music, automated translation, analysis of video action, sequence study of the genome and DNA. Okay, so this is few example. There's a code one. Same we can use TensorFlow, Keras, and PyTorch. There is nothing change. Same we need to call Keras sequential model here. This is comes with some FAQs for your people interview or campus placement. What are recurrent neural networks? Any answer, guys? What are recurrent neural networks? Who is going to explain? It's fine. You people can see it, and whatever you are understanding, we can explain it. That is also I am very happy. Just unmute yourself and start. What are recurrent neural networks? RNN. Guys. It's fine. Wrong also fine. You can see my screen, right? Is my screen visible or not?
Visible, ma'am.
Yeah. Okay. So it's fine. What you people are understanding that what is RNN? You can explain it 2-3 words also fine. Who is going to explain? Guys, be fast. They will get the marks, extra mark for the internship one. You people can add in your CV.
RNN
Try to.
uses previous data or information for the next task. It is used for like
Yes.
stock price predictions or time series.
Yes, good one. It is usually dealing with the sequential data, which is passing the previous information to the further one. Fine. Yeah, good one. How does a recurrent neural network is working?
படிங்க.
Yeah, please. The same only yes, the previous one, it is processing the next. Okay. Okay. How ANN is different from RNN? Any answer for it?
It has memory, ma'am, to store the data.
Sorry.
It has memory to store the data, ma'am.
Yeah. In ANN, there is nothing like sequence data needed. RNN means the data needs to be in a sequence. Okay. How many activation functions are there in neural networks or in deep learning? How many activation functions are there?
4.
Okay. Can you give example, Shri?
Softmax.
Yeah, softmax. Yes. Yes, Harshvardhan. Tell me.
Sigmoid.
Sigmoid, yes.
ReLU.
And tangential.
ReLU and 10H.
Yes.
So, popularly, what we are using? Most popularly, what we are using?
For multiclass, we use softmax. For
Okay.
binary, sigmoid.
Sigmoid. Okay, and ReLU?
Don't know. I think liquid area also a activation function.
Yeah, ReLU also active. ReLU is the most popular, softmax also. Sigmoid is we are using less because it is taking the E value. ReLU is the simple one, so we are using more. Okay, fine. So, guys, now what is epochs? What is epochs?
One complete data set training. One
Yeah.
cycle of training.
One cycle of, yes, the completely total data rows will run one time and it will return the accuracy result. So, okay, what is the difference between cost function and loss function? These are the question in interview, mock interview, placement interview, everywhere you will get. What is the difference between loss function and activation function? Yeah. Loss function means what we have actually and what we predicted. Actual minus predicted. This is called loss for one row. When we are going for the summation of total row and finding the actual minus predicted, then it is loss. Fine, this is the loss one. Okay, now, you people let me know what is classification report. What are the major steps in classification report? Because classification report we are using for what? We are using for the validation of our model. Fine. So, what are the things are coming in classification report? What are the major things are coming in classification report? Guys, this is here only classification report. We are taking the classification report, what we are having actually and from there we prediction, recall, F1 support, attendance support, and support. Fine. Okay, this is classification report. Okay. Fine. Okay. Okay. So guys, there is one thing. We are using box plot. So guys, I have some questions like how we are handling the outliers. For example, how we know there is outlier present or not by using which techniques? Any answer? We can use box plot. See here, these are the outliers. We can use box plot and we can find out, okay, outliers are in this column. After finding the outliers are in these columns, then how we can remove or how we can drop the outliers? Any answer? Please go for little feature engineering. Fine. So, okay, this is done. Guys, anyone having any doubt on ANN? I think ANN is clear now, and RNN also you people got some idea, right? So tomorrow we'll do practice RNN LSTM. Okay. Okay. Guys, any more doubt, guys? Please let me know. Feel free to ask. It's fine.